Hello everyone, my name is Jacob Buell. This video is about Lab 4 oscillations for the class of Physics 2211. So as an introduction to this lab experiment, the aim of this lab experiment is to examine the motion of a vertically oscillating mass on a spring. So this will be done by tracking real-world data from a video and creating a computational GlowScript model. Some background knowledge is needed, and these are the effects of Newton's laws and systems of energy. So Newton's second law. Newton's second law of motion states that the net force is the change in momentum over time. So this can be written as F net equals ma or F net equals dp over dt. Now, Newton's second law of motion can be used to derive position and velocity update formulas. So the position update formula is the final position would be equal to the initial plus the velocity times change in time. And the velocity update formula is the final velocity is equal to the initial velocity plus the acceleration times the change in time. Now in this case, acceleration can also be taken as the F net over the mass. Now the total energy, for the energy of the system, we just know that the total energy can be calculated as the sum of the total change in kinetic energy and potential energy. It is also calculated as the sum of work and the change in heat of the system. So you see the change in energy is equal to W plus Q. Now for kinetic potential energy, just kinetic energy, it equals 1/2 mv squared. So the change would be 1/2 mv final squared minus 1/2 mv initial squared. Spring potential energy is just 1/2 ks squared, and S in this case would be the just like stretched or compressed length minus the relaxed length of the spring. And the gravitational potential energy is mgy, and so the change in that would be mg change in y, or the change in height, and this can only be for objects close to the surface of the Earth. Now for the system and surroundings in this lab. The system in this code experiment is the spring, Earth, and the mass. And the surroundings are everything else, but it can be thought of as just nothing. So in this lab, I used the tracker software to get the X and Y position data of an oscillating mass from a video recording into a CSV file. I created a GlowScript model to simulate the oscillation of the mass and compare it to the tracked data from the CSV file. And I also plot the energy changes that is computed in the model. So here's an analysis of the tracker. You can see the X and Y position over time, basically. So the object mass was 0.402 kilograms. Video frames per second that we used for the tracker software is 10.5 frames per second. The initial position and initial velocity are seen there. Now for the GlowScript model, some constraints for the gravitational acceleration at the Earth, so 9.8. Spring constant was discovered at 6.83. And same for the relaxed length of the spring, which is 0.123. So here are the results of the GlowScript model. So the top left graph is the X position over time, top right is Y position over time, and the bottom is the change in energy over time. So this compares the GlowScript model versus the experiment. So you can see they are fairly close, a little bit off on the Y position. But what's most important is in the change in energy graph is that the total energy is constant, the orange line. You can see the potential kinetic energy oscillating back and forth, but what's important is that they equal 0 because there's no force applied to the system, or no work done to the system. So what does this mean? The energy principle, of course, is satisfied because the graph shows that the total energy remains constant. This is correct because we chose our system to have no external work applied to it, because our system was everything. Therefore, the change in energy is 0. By looking at the tracked X position data and the tracked Y position data, it can be determined that the period of oscillation is smaller in the Y position. So these differences can most likely be caused by external drag forces that were just not taken into account.